In this question, we're given some graphs and asked to find out which of them represents the information provided in the scenario. Okay, so let's take a look at the first sentence. Raven starts 6 meters away from a motion detector. So the 6 meters away tells us that we're looking at a distance, and we can see on our graphs that distance is the vertical axis in each case. So Raven would be here in this case, would be here in this case, etc. It looks like all of the graphs are true so far. And the motion detector would be here, 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 and here. So let's verify. So if this is the motion detector here, Raven is 6 meters away, that's true. On this scenario, here's the motion detector, Raven's 6 meters away, that's true. Motion detector's here, Raven's 6 meters away, that's true. And the same for option D. So far, all graphs are correct. Now let's look at the second part here. She walks quickly toward the motion detector. So if she's walking toward the motion detector, so if we look at this option here, then she would be coming this way. And quickly means that the slope of the line would be fairly steep. So she's walking toward, that's true here. So in other words, she's not walking away, which would be represented by a line going up. So option A looks like it's fine so far. Option B, she's walking toward, yes, and the slope is fairly steep, so we could say, all right, that would hold true so far. Option C, again, she's walking toward and it's fairly steep. Option D, walking toward, not as steep, but could still represent the scenario. Okay, let's bring in more information. She stops 2 meters from the detector. Okay, so on our distance axis, let's put in like there's 2 meters away, there's 4 meters away, etc. Now let's look at the graph. So let's look at A. She starts 6 meters away, walks quickly towards it, and stops 2 meters away. And here we can see that this is true right here. She stops 2 meters away, which means over time, which is the horizontal axis, she's just going to sit there for a couple of seconds or so. So A is still in the running, is correct. Let's look at B. She starts 6 meters away, walks quickly towards, and stops 2 meters away, which in this case we could say is still probably true. Now let's look at C. Starts 6 meters away, walks quickly towards, but if we see here, she's right at the distance between the detector and her is 0, so she's not 2 meters away, which would be up here. She is actually right by the detector. So right away we know that that's incorrect. We can eliminate that possibility there. And the same is true for graph D. If she starts 6 meters away, walks quickly towards, we can see that she's right by the detector here again. So that option's been eliminated. Okay, so let's bring in the last pieces of information. So she stops there for a moment, which we've talked about already, and then backs away from it slowly. So the word slowly here would tell us that the slope would not be steep, it would be fairly gradual. So let's look at A. Starts 6 meters away, walks quickly towards the detector, stops for a moment, in other words the distance is not going to change for a couple of seconds or so, and then she walks slowly away. So she's walking away, which means going away from the detector, and the slope is fairly gradual, so this looks like it is an accurate representation of the scenario. But then let's confirm with B. So she starts 6 meters away, walks quickly towards it, and we've already determined that that slope is not really quick. It could represent it, but we're not sure. Stops for a moment 2 meters away. Okay, well that's true. And then here she's walking away, but at a much faster pace. So she's walking quickly away here because the slope is fairly steep. So therefore we can see that option D, or B I should say, is not the right answer, and indeed it's option A.